Python's language than the others. Yeah.
Really?
Yeah. The other language I think is too old, but in China it's still very famous because every computer sciencer has a comfortable language. Yeah, best.
You said in China they learn C.
C. Yeah.
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 Very old now.
Yeah. Very old.
Python is popular.
Yeah.
And Java is still popular.
Yeah. Java is popular for a long time. I think.
Yeah, it's very popular for a long time.
Yeah.
I don't really like Java. I like Python. Python's a nice language. You know some Python?
I just watched the first class to Python because I don't know. I don't know. When I arrived at Ireland, I think I will learn the computer class maybe. So I watched the Python's. But when I arrived, I found I just need to learn physics and math.
It's strange because NCUK, they used to do computer class, but they don't anymore. I don't know why. I think they should have a programming class.
Yeah, program class I think is.
Because you would probably prefer to do that instead of chemistry, right? Yeah. Because the Chinese students with poor English, well, not poor English, but English not as good as maybe the students from Africa.
Yeah. Because
it's difficult for them.
Our language had too many different from the English, but their language had
similar.
Same.
It's difficult.
Yeah.
But you will learn it next year. I think it's good to learn some now, because I learned Python online. You know,
online, I know.
Just by myself.
Online class.
Yeah. It's easy.
Yeah, the beginning. I say the class. The beginning is easy, but if you use the Python to make the program, you need make your brain like computers.
I just know a little bit of Python for making small programs. You know, just simple little programs. Nothing professional. Yeah. You're going to do AI next year? Maybe.
Because I prefer to make the I don't know what's the word. Just a computer like humans. Make the computer more like humans. Yeah.
That's good. Do you know where you're going to study?
Actually, I want to go to the better college like TCD or DCU, but I think the class is too difficult.
It's entry is very difficult.
Yeah.
It's very, very hard. You know,
it's very hard.
They want good high school, and it's just so difficult. You know.
So I think I should try the Dublin City University or college.
DIT? DCU?
DCU.
DCU is good.
It's Dublin City
University.
University,
Yeah, DCU.
Yeah, but I think it's a little easy than the TCD or.
It's easier than TCD, but it's still difficult.
Yeah. Because the computer science is difficult.
Yeah. Anyways, I think, you know, in Ireland it doesn't really matter so much, maybe not as much as in China. There's some good universities outside Dublin, you know, Cork, Galway. And you can always study a master's. You know, master's? MSc?
Yeah, I know.
So like if you, for example, studied in Galway, you could do a master's in TCD. or DCU.
Oh.
You know?
Yeah.
Like, for example, in Ireland, like for me,
Yeah.
I studied in TCD,
Yeah.
and then I did a master's in UCD.
Oh.
You know, but it doesn't matter. You know, you could study in one university and do a master's in another. There's no problem transfer. You know, the only thing they care about is your grade. You need to get at least a B.
At least a B.
Yeah, if you get a B, then you can do a master's in any school.
Yeah.
You know.
Oh, that's great.
So, like, if you really want to go to TCD,
Yeah.
you could go to DCU first,
Yeah.
and then you can do your master's in TCD.
Yeah.
Because TCD has masters in computers.
Yeah, and
Yeah.
there is my brothers want to study the masters in TCD, but in his university he didn't study the computer. Yeah.
That might be a
It's
problem.
too difficult.
I think that's a problem. Yeah. Anyways, we'll continue now.
Okay.
This is our next topic. If you want to write this down, you got paper? Yeah. Moments and center of gravity. Oh dear. Yeah. Now, it's not so difficult today, but there's a few things to look at. So, do you know what this means, center of gravity?
Like.
Yeah.
Yeah. Maybe
Yes.
maybe it's here
Yeah.
or this is.
Exactly.
Yeah.
Exactly. So we say the center of gravity of an object is the point where all the weight of the body acts.
Yeah.
So it's the special point where all the weight
Yeah.
acts. So the center of gravity is like where the weight vector is. How the mass is spread out will affect where it is. So it's kind of like an average. So for example, well, you know what? I have some pictures. We'll do some pictures now in a moment. So you see these three pictures.
Yeah.
The center of gravity is different in each person because of the mass. So this one is higher.
Yeah.
Why is this one higher?
Because the whole toss is higher.
It's higher, yeah. Taller, yeah.
It's taller.
And can you see this one is to the side
Yeah.
because of the bag?
Yeah.
And this one is forward because she's leaning backwards.
Yeah.
So, of the three people, who is most likely to fall? Who do you think will fall? Most likely to fall down?
I think. Maybe
Yeah.
is a C.
C, you think?
But no. Maybe is a B.
B, you think?
But I think if the central gravity in here he is not easy to fall. But I think the fathers can't be for.
Okay, true.
Yeah.
He should be more careful.
Yeah.
I guess my point was, I should say, who has the hardest job? It's A.
Yeah.
Because it's more easy to make him fall because this is higher.
It's higher. Yeah. I think the father.
But I understand your point. I understand your point. So, fulcrum is another word for what we call a turning point or a pivot. Now, I'll show you that here.
Yeah.
You see these?
Yeah, I see that.
That's called a pivot or a turning point.
Turning point. Yeah.
So, or a fulcrum.
Yeah.
But you know, when I walk,
Yeah.
this here is a fulcrum because I'm turning.
Yeah.
Or you know, like if I don't know, like here is a fulcrum. Then. Yeah. So you can use this word, or this word.
Yeah.
But I think this is the best one because it's the physics word.
Yeah.
These are like general English.
Yeah.
Turning point or pivot is what this is. You know,
Yeah. I know.
okay, so can you write those words down?
Okay. What's the pronunciation?
Fulcrum.
Fulcrum.
Yeah. Yeah? Okay. Now, the hinge on a door, the seesaw is what the children played on, the wheels, the foot on the ground, these are all examples. Okay, so notice how the centre of gravity is quite high. Yeah?
Yeah.
And also, the base, her hands are quite small. So it will be very easy to make her fall. You know, you just push her a little bit and she falls. We call this picture very unstable. So what you need to write down, you could make a table, okay? So you could have center of gravity and base. Oh, sorry, that's silly. I'll do it like this. Center of gravity and base. So the center of gravity in this picture here. Okay, so we have 1, 2, 3, and then like this, I think. So the center of gravity here is above, and the base here is small.
Yeah.
So if you have it like this, then you are very unstable.
Yeah.
If the turning point is above and the base is small, very unstable. Okay, so this one here is unstable, but it's not very unstable. The turning point is above, but the base is it's large, it's big. So we just say it's unstable. Not very unstable, just unstable. Okay. Have you seen these toys before?
Yeah.
You have this in China with the bird balances on your finger.
Balance on?
Yeah. Have you seen this toy? No.
No.
So this.
It's like the.
No, not like this. It's a bird. Can you see it's a bird?
Yeah, I see.
And you can put on your finger and it doesn't fall. Doesn't fall. Because they made the center of gravity at the beak.
Oh.
So it's perfectly balanced. Like the center of gravity is right on the beak. Yeah. Like that, yeah. So in this one here, the turning point is at the turning point is at the center of gravity, kind of like here. Yeah. And the base, well, it's not really important if it's big or small. So in both these cases, we say it's neutral. Yeah. I mean, if you hit it, maybe it won't fall, but it will move. You know, like it will move around. Well, maybe it is like the spinners. Yeah. So next one, if you hang from something, so the turning point is below. Oh, sorry, the center of gravity is below the fulcrum, and also the base here is small. So base is small, and here we have below. So we say this is stable. And then the last one is, you can see, is below and a big base. So that's like this. The center of gravity is below, and the base is very big. It's very long. So this is very stable. You know, so if you hit this, it will always come back. Yeah, it won't fall. So these are kind of like, we have 3 situations: above, at, and below. So you can also think of it like this. You can be like this. You can be like this, or you can be like this. In this case here, if you give a little force, you'll fall. Here, if you give a little force, you'll move, but maybe you won't fall. And here, if you give a little force, you don't fall because you just swing back to the center. So actually, this is most stable. Now, I know, of course, maybe you can let go, but you get the idea. You can also see this in cars as well. You know, if you have a car like this or a car like this, if they turn the corner, these ones sometimes they fall. And the reason is because the center of gravity higher. So it's more unstable. Okay, can you maybe draw this or write this in your notebook?
It's TROL, natural.
Neutral. Neutral. Right. So the moment of a force is the force times the perpendicular distance from the fulcrum to the line of action. So it's a turning force. It's also called a moment or torque. And this is the formula. I need to explain this. I don't know what letter to use. I use L, but anyways, like for example, here is maybe this is like a door, you know, and you pull here with a force. So we can say the turning force is equal to the distance multiplied by the force. Only if it's perpendicular. Now what about if you have this? If you pull at an angle, and this is the distance, you have 2 choices.
Sine and cosine.
You could, you could get this and this, and if this angle is theta, then this one here is f sine theta. So you could say d equal, not d, sorry, what am I saying? L equals df sine theta. Now you don't care about this one. Why not? Because it goes through the turning point. Yeah, and it can't make it turn.
Yeah.
But another way to do it is like this. And this is D. So what you could do, you could draw a line here
Yeah,
and get this distance. We call that D. And you could say, or you could say L equals this multiply F. So you get the same answer. Same answer. Oh yeah.
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 Oh yeah. It's the same.
It has to be the same.
Yeah.
Yeah. So sometimes it's easier to do this, and sometimes it's easier to do this. You know, it depends on the situation. Yeah. So this is what we mean by the turning force. Now sometimes I use this symbol. Sometimes I use this. I don't know what you used in China.
Maybe they still use this.
Still F.
Yeah, because it's
like a force. It's like a force. Yeah. And the units, of course, are Newton meters.
Yeah.
Newton meters. And we can call this a moment or a torque, but it's just a turn-in force. Yeah. I don't know which I like. I think I'll stick with using L.
Yeah, maybe I forgot that. Yeah.
We'll use L.
Yeah. We will use L.
Yeah. Okay, so you need to write these words down in this formula.
Okay. Oh, it's too long. Oh, I think if now I started learn the Python, when I go to the university, it could be easier.
I think so too.
Because when I started learning in college, there must be more difficult English in class.
There will be more difficult English, for sure.
Yeah. Because the IT in Chinese college is also difficult.
Yeah.
And they need to learn more math, difficult math.
Yeah.
It's I don't know how to say in English. It's a higher math.
Yeah.
Yeah. Oh, I'm afraid if I don't understand the difficult English meanings, maybe I can't realize the
don't worry. You have lots of time to practice your English, improve your English. Yeah. Okay, so this measures how much turning effect there is. A big moment means there's a lot of turning force. You know this little picture.
Yeah.
If you make this longer,
you
can. It's easier to turn. Yeah. There's a very important problem called a couple in physics. Because you see here in this picture, it's turning, and there's two forces, and they're the same.
Yeah.
And this is turning, and there's two forces, and it's the same. Now these forces must be equal because the wheel doesn't move up.
Yeah.
And these must be equal.
Yeah.
Must be equal because this doesn't, it only turns, it doesn't move left or right. This is a special type of system, two equal opposite forces, and they're the same distance from the pivot. It's called a couple. So it looks like this. You have a force here, a force here, and we'll call this distance D. So the total turning force will be this one, which is D over 2 times F. And then this one also makes it turn the same way. So plus D over 2F. So that's equal to DF. Yeah, just this times this.
Little question.
Yeah.
If this force is bigger than this, the wheels will rolling, and if they are balanced, the wheels also rolling.
Yeah, but I don't.
The force is.
Yeah, no. This could be bigger.
Yeah.
But if it's bigger, this will happen. So let's say this is big F and this one here is small f. So it'll still turn, but the problem is now you get a reaction here. Because if you didn't, then the wheel would break off. It's a steering wheel, you know. So, you know, like
if a driving car, and the middle of the wheels will react the force.
If they're not equal. So if this is equal, then the only reaction here is for the weight of the wheel. But if this is bigger than this, then this reaction increases. Good. Okay, so a couple is two equal but opposite forces, a distance d apart. It causes the object to rotate, that means turn, but not move linearly. The total is Fd. So what I mean here is these must be equal so that it doesn't move up. So that's what I mean when I say does not move linearly. And the total is Fd. Okay, so maybe you should write this down.
Maybe when I went to I go to the college, there will be a lesson like EAP.
No. You could go to English support. Like what do I mean? You can do English classes, but they're optional. You know what I mean? Like you don't have to do them. Like no grade, just for practice. You know?
I know that. I know that means,
Why, in China, must you study EAP at university?
It's
or is it only Chinese? You don't study English at university?
No. It's a master study. We must study English in university because there is a big exam to for us. Yeah, it's
You must study English.
yeah. The exam's name is English 4 levels and the English 6 level and the English 8 levels. It's like else, but it's a Chinese government. Yeah.
But it's like IELTS.
Yeah, it's
Yeah.
like else.
Okay.
Yeah. It's just a Chinese test. Yeah, Chinese test. Yeah. Just to practice Chinese English. Chinglish.
Chinglish.
Yeah. Chinglish.
Yeah.
Because the test don't have the speaking.
Really?
Things. Yeah.
No speaking.
No speaking. Yeah. The education government the education part of the government just one task to write.
Yeah.
To know how to write
Yeah.
that and
How to read.
yeah.
Ah. That's strange.
Yeah, it's strange.
I know the students told me in high school there's no speaking
Yeah.
English.
There is not in our high schools we don't have the speaking test. Just listening and reading and writing. And the teachers learn is also the Chinglish. Yeah.
So, how did you practice your speaking before you came here? Did you practice with friends? Or?
In the last year, I went to Australia.
Oh, great!
Yeah.
You practice your English there?
Yeah. But I think I just my I don't know so much words, but I can speak to the English speakers easily because I speak that a lot than the other Chinese guys.
Yeah. But you need more vocabulary.
Yeah. I just know the easy words. Yeah. The hard words is less.
Yes. Okay, you got that?
Yeah.
Right. Okay, so here's a very simple question. A man is trying to free his car. He uses a 2.2 steel pole. He puts the steel pole onto the car wheel and then uses a large brick as a pivot. The brick is 20 centimeters away from the end of the pole. So anyways, the picture looks like this. He's got 2.2 meters and then he puts a little brick here and this is 0.2 meters and this is 2 meters. And he pushes down here with 1 kilonewton. And we want to know what is the turning force here. Well, that's going to be 2 because that's the fulcrum. 2 times 1,000. Yeah, so 2,000 Newton meters. A little simple little question. Okay. A wrench is used to tighten a nut. You know, like I'll draw it for you. It looks like this.
Oh.
You know it?
Yeah, I know what.
Okay, good. I don't have to draw more. So it has a nut. You get the idea. And you use to tighten it. What's the moment? What's the turning force? Well, it's going to be 0.2 multiplied by 100. 100. So like, if you're here with 100 newtons, and you're making this turn, and this is 0.2 meters, so that'll be 20 Newton meters is the turning force. That's easy also, isn't it? Okay, the steering wheel, 5 newtons up, 5 newtons down. So what's the total here for the couple? It'll be 5 multiplied by 0.3, 1.5, isn't it?
Yeah, 0.15, yeah.
0.15? Or 1.5?
1? 5 newtons. Oh, yeah, it's 1.5.
1.5.
Yeah.
Newtons, okay. Yeah, that's all. So, let's see, the questions. Baby questions. Easy questions.
What is the state?
Yeah, so easy, huh?
Yeah.
So, why don't you try these questions now? And then, yeah, you can try these for 10 minutes. I think you should get these finished in 10 minutes. Yeah, easy peasy.